You are standing in a swamp 375 million years ago during the Devonian period of Earth's history. You are about to take a motorboat along a river system out to the open sea to discover some of the prehistoric animals that ruled the rivers, reefs, and oceans. This period is called the Age of Fishes, and it's easy to see why. There were monstrous giants larger than a car with interlocking teeth like blades, early sharks with flat fins like ironing boards, creepy conodonts without jaws, and even the first fish to walk on dry land. You are standing on the banks of a caramel-coloured river surrounded by strange alien plants. A deep rumble of thunder rolls through the gathering clouds. A light drizzle develops into a warm rain, which drums a steady beat against the river, creating a fine mist of dancing droplets that appears to hover above the murky brown water. There's a rich, earthy smell of ozone and decay in the warm Devonian air. As water pours down the sides of the river, the banks hold in place with a new strength that the land had never experienced before. For the first time on Earth, there were plants with roots deep enough to stabilize soils and riverbanks and preserve the shape of the river. You bend down and pick up something weird buried in the mud. It's a flat, round bone, which kind of looks like a turtle shell. But this far back in time, turtles don't exist yet. This is part of an armor-plated fish skull. Bothrialepis, maybe. Despite the rain, this Devonian swamp is strangely quiet. There are no birds singing and no insects buzzing, no frogs croaking, no small animals shuffling through fallen leaves, and nothing breaks branches as they move. But in the water, there is something. You look at ripples spreading nearby. You take a step to look closer, and your foot sinks down as far as your shin in sticky brown clay. You reach at a fern for support, but you rip off the entire frond and fall. You land awkwardly in the water up to your knees, and a huge animal lurking in the shallows thrashes in surprise. It's something gigantic. With a flick of a tail and the flailing of fins, you watch ripples moving to the opposite bank. It crawls up on land, scrambling from the water over roots and rocks. This river dweller pauses on the embankment, flat on its belly, and stares at you with tiny, wet eyes. It's a large fish called Tiktaalik, with an elongated 2-meter-long body, a flat triangular head, tiny eyes that pop up, and a long tail with a tapering fin. It is a lobe-finned fish, and it has a revolutionary set of adaptations that make it one of the first vertebrates to live on land. It has strong bones in its lobe-shaped fins that allow it to walk, and importantly, it breathes with both gills and lungs, making it a curious transitional animal between fish and amphibians. It's a thrill to see one. Tiktaalik remains completely still under the rain and looks over at you with its tiny beady eyes. After several minutes, it moves its head. It decides the coast is clear, and silently it slides back into the river and disappears. The lazy, unnamed river you're exploring is on a continent called Laurasia, also called Euramerica. It formed when the ancient continental cratons of Laurentia and Baltica were crumpled together by huge tectonic forces. Closer to the modern day, Laurasia would one day rift apart into pieces of North America, Greenland, and Europe. This ancient river would one day be part of Scotland, or perhaps Canada. To the north, there are ancient cratons that would one day be part of Siberia, Kazakhstan, and South China, while the great continent of Gondwana in the south was shifting slowly northward on an unstoppable collision course. In the Devonian, all of these island continents were positioning themselves to one day accrete together to form the supercontinent of Pangaea. In the latest Devonian, some ice caps would form on Gondwana as part of the Karoo Ice Age, but most of the Devonian was a hot, humid world. The sea levels fluctuated up and down significantly throughout the Devonian, but for a large part of it, the oceans and seas covered around 85% of the globe. As you climb out of the river, embarrassed and covered in mud, You look around at the strange science fiction swamp plants around you. The riverbanks are supported with large rocks and slippery mosses that are clogged with filaments of charophyte algae and decaying fern fronds. They form festering pools that crawl with tiny spiders called Placoderms. The plants here don't have many features that modern plants do. You won't find a single flower, fruit, or even seed in this swamp. Instead, there are an abundance of feathery, spore-bearing plants. You walk along the riverbank until you reach your motorboat. You untie it from a nearby plant and start the motor. You are heading downriver to where the river expands into a shallow estuary, and eventually out towards the ocean. A school of small freshwater fish dart out of the way of the boat, and some of their armoured heads clang against the side of the boat as they scramble and change direction. Under the rain, you admire some of the Devonian plants that populate the swamp. There's a grouping of humongous Equisitopsida over there, also known as horsetails. They have a hollow segmented stem that fans out in circular patterns like a brush. These plants still exist as small versions in the modern day, but in the Devonian, they are giants. Over on the other bank you see lycophytes like club mosses and fir mosses. Nearby is Archaeocigularia with strange curled stems. Your hands are stained green from ripping at the fern frond. You rub them together, cleaning them under the warm rain. These iconic plants first appeared in the Middle Devonian. They have true roots, stems, and frond-like leaves which bear spores for reproduction. The real giants of the Devonian were the first progymnosperm trees called Archaeopteros. They had solid wood-like trunks that branched out spirally into leafy fern-like fronds that carried spores. They grew to huge sizes, every bit as big as some modern trees, and could have reached heights as much as 24 meters tall and 1.5 meters wide. They weren't alone either. Other progymnosperm relatives like Relimia and Aneurophyton are more woody plants from this period that helped to build the first forests. Plants like these were becoming better suited to living away from water sources. They had vascular systems to transport water and nutrients throughout the plant. While the first lobe-finned fish like Tiktaalik were making their first excursions onto the land, some other animals had already been dominating the terrestrial environment for tens of millions of years. They are the arthropods. With plants, the producers, and fungi, the decomposers, long in place, the food webs were now being populated by higher level consumers. The terrestrial food web was taking shape. Tiny, millimeter-long insects called Rhyniella crawled across the forest floor and along plants, scavenging plant material alongside other herbivorous arthropods like Campicaris, one of the earliest millipedes. One level up in the food chain were primitive spiders called Paleocarinus, which measured less than half a centimeter long. They breathed using simple lungs made of layers of tissue and air called book lungs, and had large fangs to immobilize their prey. Another group that thrived in these Devonian forests were the Opiliones, also known as harvestmen. Although they look superficially like spiders, they are only distant relatives. You reach the end of the river and the waterway fans out into the shallow estuary. It's mostly flat, but you hear the roar of waves far away in the distance. You slow down and slalom in between calcareous outcrops of a colossal reef system. It reaches above the waves, encrusted with the shells of brachiopods and mollusks. The rain keeps falling as you look down through the crystal clear water to the secret world below. If you thought that the reefs of the Silurian were wonderful, this is next level. The Devonian period was the golden age for reefs, which reached their pinnacle of size and diversity all across the globe. These Paleozoic reefs were built around calcareous stromatoporoid sponge structures, rugose corals and tabulate corals, coralline algae and bryozoans. They've been building hard structures for tens of millions of years, and some of them could be hundreds of meters high. we can find entire ancient reefs fossilized, which we call bioherms. You cut the engine and slow your boat down so you can take a close look at some of the animals underwater. The first thing you notice are crinoids, relatives of starfish that are now growing to gargantuan proportions. They are made of a crown that has 5 feathery branching arms coming from a central crown, supported by a long calcified stalk that attaches to the seafloor. How is this possible? In the deeper water, you see indescribably huge crinoids called Taxocrinus ceratogensis, moving their arms as they collect detritus from the sea. They've been recorded as high as 12 meters tall. That's as tall as a 3-story house, with crowns spread out over 3 meters wide. They might weigh more than 10 tons each. Down below you see another inhabitant of the Devonian Reef. Brachiopods, the dominant shelled organisms of the time. Also called lamp shells, they look a bit like clams which attach to the seafloor on a stalk, or live freely on the seabed. There are some recognizable ones down there, like the long-hinged Spirifer and Productida, known for its wild spiky shells. The reef is alive with other reef-building organisms such as trilobites, graptolites, and mollusks, creating thriving and beautiful underwater communities. But where there are producers and low-level detritivores making up the primary consumers, there are high levels of carnivores. Some of the largest arthropod predators ever recorded lived in these Devonian reefs, such as the terrifying 2.5-meter long Eurypterid Jaekelopterus. This sea scorpion had developed huge claws for grasping that had been measured up to 46 centimeters in length, nearly as long as your hand and forearm put together. In the Devonian, one of the most famous prehistoric creatures of all time appears, the ammonoids. This newest group of cephalopods are instantly recognizable for their coiled shells that resemble ram's horns and are some of the most abundant of all fossil animals. They lived in shallow oceans and probably hunted for small prey around the reefs. They used chambers in their shell called septa to control their buoyancy, just like a modern nautilus. Ammonoids used an evolutionary strategy of being extremely abundant, with short lifespans and large numbers of offspring. There are some armoured fish patrolling the seafloor, bottom feeders with jaws like Bothrialepis, tiny sharks, and more primitive jawless cousins thriving. You move on, continuing past the corals and crinoids and the furthest reaches out past the sponge reef, and reach open waters of the mighty Panthalassic Ocean. The clouds clear and the rain has stopped. You feel a warm, salty sea breeze passing over the water. The ominous blue depths of the Panthalassic Ocean stretches below you. This is the realm of the largest fish, and during the Devonian, some have started to reach truly epic proportions. Deep below you in those blue depths, fish had been diversifying in an extraordinary way for tens of millions of years. Early in the Devonian, there were many groups of armoured fish called ostracoderms, which can be divided into various subgroups such as the osteostracans and heterostracans. They had no jaws, armoured heads, and simple body shapes. Others developed long nasal spikes or elaborate protrusions sticking out of the sides, like the flamboyant Lungmentionaspis and Doriaspis. They were some of the first fish to develop paired fins, and were the precursors for some of the most dominant fish groups. The Chondrichthyans, the group that includes sharks, first appeared in the Silurian and now diversified into many different forms. One of these Devonian creatures is Cladocelash, a fast-moving, agile predator that could grow up to 2 meters long. It had a distinctive double dorsal fin, oversized pectoral fins, and a forked tail. In the late Devonian and onwards into the Carboniferous, one of the strangest sharks yet appears in the oceans. Stethocanthus was a small shark with a raised dorsal fin that looked like an anvil or an ironing board, covered in modified scales called denticles. This fin is only found in males, and may have been used as a sexual display. When swimming, it probably caused significant drag and was likely a slow-moving bottom feeder. While many Devonian sharks were carnivores, they were not the apex predators of the period. That title went to another group of Devonian fish, the Placoderms, a class of fish with heavily armoured bony heads, soft flexible bodies with pectoral and pelvic fins, and sharp interlocking bony plates for teeth. The most recognisable placoderm of the period is also one of the biggest. It's called Dunkleosteus, and is one of the most famous animals of the Devonian. The only Dunkleosteus fossils we have are of its massive armoured head section, which could grow up to 70 centimetres long. It had a distinctive short snout, piercing eyes with armoured sclerotic rings, and teeth blades that were extensions of its external armour. Studies on the jaws estimate that it could open its mouth in 20 milliseconds and snap them closed almost as quickly. The force of its bite is thought to be more than 4,400 newtons, one of the most savage bites of any animal ever recorded, and one that could easily shatter an ammonoid shell. Because no soft body parts have ever been found, the exact morphology and size of Dunkleosteus is not known, but recent studies suggest that it was about 5 meters long. And it wasn't the only giant in the oceans. It had massive cousins too, like Gorgonichthyes, which had oversized lower jaw blades and was comparable in size to Dunkleosteus. As you steer your boat over the calm ocean waves, the silhouette of another colossal armoured fish appears just underneath. It's an even larger giant of the deep called Titanichthyes, which may have measured up to 7.6 meters long, about the size of a killer whale. Like other placoderms, it had a heavily armoured head with bony plates for teeth. However, they were not sharp cutting elements like Dunkleosteus. Instead, Titanichthyes was probably a trawler, holding its massive 1 meter long lower jaw wide open to filter small fish or plankton out of the water, just like a modern basking shark. Its relative Heterosteus was another gentle giant, with a wide, flat, armoured body, small protruding eyes, and was likely planktivorous. Not all placoderms were gigantic deep-sea creatures. Many were small fish that lived near the sea floor. Bothrialepis was a highly successful placoderm with over 60 recorded species. It had a flat armoured head and scale armour covering its 2 spine-like dorsal fins. Most species measured about 30 centimeters long, and they ate decomposing matter in shallow waters. Its relative Gemundina lived a similar lifestyle, with a wide and flat body like an armoured ray, while Murundalaspis had a spectacular bony crest on its head armour. While the placoderms used tough bony armour to defend themselves, many other types of fish had soft bodies built for speed. By the mid-Devonian, the Osteichthyes, or bony fish, had established themselves into 2 distinct classes: the Actinopterygians, also known as the ray-finned fish, and the Sarcopterygians, known as the lobe-finned fishes. The ray-finned fish are the ancestors of most species of extant fish today, a hugely successful group that today ranges from goldfish to tuna to lionfish and even seahorses. They have thin paired fins made up with fin rays, small bones that fan out and are supported by parallel bones called radials. In the Devonian, primitive ray-finned fish include Chirolepis, a half-meter predatory freshwater fish that had large forward-positioned eyes for hunting prey. Lobe-finned fish, on the other hand, have fleshy lobe-like pectoral fins supported by bone and muscle, and connected to the rest of the skeleton with a single bone. Some of the lobe-finned fish were very large, such as Hyneria, which could grow up to 3 meters long and hunted prey in the murky waters of river habitats. In the late Devonian, the lobe-finned fish were developing their unique party trick. In the slow, variable world of muddy riverways, some of them evolved adaptations to make them amphibious. And here's the cool part. Thanks to an incredibly complete record of transitional fossils, we can track how fish evolved almost step by step into the earliest tetrapods, the four-limbed vertebrates that would later branch into all amphibians, reptiles, birds, mammals, and eventually us. Let's go back in time a little bit to 385 million years ago, 10 million years before your adventure in the Devonian swamp. It's humid and sunny. A 2-meter-long aquatic fish called Eusthenopteron is swimming through the murky waterways, using a mouthful of pointed teeth to catch small fish. It had gills for respiration in water, and lungs for drier conditions. Inside its fins, its bones began to correspond with the common bones of a tetrapod limb. Now, let's go 5 million years later to 380 million years ago. Swamp gas settles over a stagnant river, reducing visibility. Underwater, a lobe-finned fish called Panderichthys is swimming around. Its head was flattened. It had lost its dorsal fins, and the forked fish tail had evolved into a long tail with a single long fin. In its limbs, it appeared to have distinct radial bones. Fast forward again to 375 million years ago. This is where Tiktaalik, the fish you already met, enters the picture. It had a flat, triangular head with small dorsal eyes and an elongated body covered in scales. This is a fish with a movable neck, shoulder bones, wrists within its fins that could support its weight to crawl out of the water. Fast forward another 10 million years to 365 million years ago, and the tetrapodomorphs, Acanthostega, and its close relative Ichthyostega were becoming even more convincing intermediates between lobe-finned fish and tetrapods. Acanthostega had 8 digits per limb linked with webbing, and while it was better suited for paddling in the shallows, these animals could come onto land with ease. Tulerpaton, another tetrapodomorph from this time, developed a new trick. Its bones allowed it to lift its head up and down. By the time the Devonian transitioned into the Carboniferous 348 million years ago, animals like pedipes were fully adapted to life on the land, even though they still needed the water to lay their eggs. The Devonian period was named after the county of Devon in southwestern England, where the first Devonian fossils were being extensively studied in the 1830s. 2 notable geologists collaborated to describe the Devonian: Roderick Murchison, who described the Silurian and the Permian periods, and Adam Sedgwick, who proposed the Cambrian. We know so many tiny details of Devonian life thanks to the Rhynie Chert, a rock formation discovered near the town of Rhynie in Scotland. The rock is called chert, which is a silica deposit with a very fine texture. The Rhynie Chert preserved plants, animals, fungi, and lichens in such incredible detail that we can see individual cells, plant cell walls, xylem tissue, and even count their stomata. In animals, some fossils of a 4mm arachnid show the delicate breathing apparatus. Meanwhile, another site called the Hunsrück Slate in Germany is filled with wonderful Lagerstätte fossils, also preserved in exquisite detail, with examples of invertebrates, jellyfish, spiny sharks, and placoderms. The Devonian was a period rich in amazing forms of life. What an amazing opportunity to get to see some of these animals for real. But a dark cloud hangs over the end of the Devonian. Around 372 million years ago, towards the end of the period, a series of mass extinctions began that combined to form the devastating Late Devonian extinction. The exact time span and cause are still being debated, with estimates ranging between 500,000 to 25 million years. It might have been caused by global glaciation that temporarily transformed Earth to an icehouse world and then back again. Or it might have been caused by volcanism, meteorite impacts, or changes in ocean chemistry caused by accelerated plant growth. Whatever caused it, the effect was calamitous, especially for marine life. 70% to 80% of all species on the planet were wiped off the Earth. In the first main extinction pulse, 372 million years ago, the Kellwasser event, reef builders like stromatoboroid sponges and rugose corals were hit hard, and entire reef ecosystems collapsed. The final extinction pulse at the end of the Devonian, 359 million years ago, was called the Hagenberg event. It was the final curtain call for many species. Many brachiopods, trilobites, graptolites, and ammonoids went extinct. The stromatoporoid sponges disappeared forever. Rugose and tabular corals persisted into the Permian, but the oceans would never again match the majesty of the Devonian Reefs ever again. The vertebrates were also profoundly affected, and the most notable loss was the complete extinction of the armoured placoderms, like Bothrialepis and Dunkleosteus, which disappeared forever. The late Devonian extinction was one of the top 5 most deadly mass extinction events ever. Many types of unique and amazing creatures would never make it out of the age of fish. But on land, the seed was planted for the first vertebrates to claim dominance from the arthropods. As the sky darkens and the sun begins to set, you steer the boat back towards the shore. You still have your Bothrialepis bone. It'll make a great souvenir from the age of fish. The air is crisp and fresh, and as the sky turns a hazy orange, you take in a moment to admire the tranquility of the scene. Oh, something is beneath you. It's a large silhouette, and it moves behind your boat, passively following you towards the reef. It's a lobe-finned fish called a coelacanth, with large eyes and 8 fleshy fins. It's an animal with a remarkable story. The coelacanths are an incredibly ancient Devonian fish, which were thought to have gone extinct at the same time as the dinosaurs, 66 million years ago at the end of the Cretaceous. But then, in 1938, fishermen off the coast of South Africa caught one, alive and well. They're still around after more than 375 million years. Today, they're found off the coasts of Africa and Indonesia, and are some of the last surviving marine lobe-finned fish still alive. As you watch it, another one joins the procession. They are lazy and slow feeders called drift hunters. They swim around with their mouths open, catching unaware fish and cephalopods. The sun dips below the horizon, and the sky transforms into a purple watercolor painting. As you clear the outer edges of the reef, you navigate between sharp sponge outcrops crusted with turban-shaped snails called Wirthenia. Your coelacanth companions have departed, diving deeper towards the darkness of the reef. With a little bit of melancholy, you realize that the spectacular golden age of fish was nearly over. But the coelacanths would endure. They would survive the incoming Devonian mass extinction, and every other mass extinction afterwards. You look down at the reef as you pass above, and see giant crinoids waving back at you. For these Devonian reefs, alive with trilobites, placoderms and sponges, their days were numbered. If you're interested in learning about the worlds of deep time, make sure to like and subscribe.